good morning, good afternoon, and good evening, and welcome back to another episode of ITProTV. I'm your host, Don Pizzette, accompanied today by Mr. Ronnie Wong. How's it going, Ronnie?
I am doing awesome today. I am doing better than any male on any Lifetime TV movie.
Well, that means you're definitely bruise-free for the morning at least. Well, Ronnie, a veritable source of energy on this Monday morning. I have not had enough coffee yet, but all right. So our goal today, Ronnie, is to put on a show where you come out at least better than Meredith Baxter Birney in a Lifetime film.
That is true. That would be awesome.
Okay, so today we're tackling some more Security Plus, right? It's a great security show for us.
That's right.
And Ronnie and I have decided to tackle the exciting, entertaining, and unusually complex area of certificate services.
That's right.
Yeah, it's one of those things that it's a key component of almost every organization's security model these days. But a lot of people don't truly understand how certificate services work and how that whole system is built upon trust and so on. And so that's what we're going to take a look at today.
Yeah, so when we start talking about the idea of certificate services for us, it's kind of strange, right? When you actually first begin working in the idea of computer security, one of the first things that we always emphasize is the idea of using passwords like crazy, okay? Anything that we do, we start putting passwords on everything. When I started, all of a sudden, my wife was now locked out of the computer and asked me, what the heck is this? Why do I have to have a password? So we started using the idea of passwords. And passwords are a good security mechanism for us. But in businesses, in corporations, we start actually needing something else, something much stronger than the idea of username and passwords. And the basic idea behind the reason why we want certificate services is to really replace that idea of really depending, I guess, upon username and password so much.
Yeah, so what we need to be aware of is that we can use certificates, like Ronnie said, to encrypt and protect our data and to provide secure communications. But there's a lot involved in using certificates. Now, most of us don't even think about it, right? We go to www.amazon.com, we click buy it now, and you know, our session becomes a secure session, right? HTTPS, and it's encrypted. But most people really don't understand the framework that's going on behind that. And there is a lot involved, and on the Security Plus exam, you need to know it, right? So that's what we're going to take a look at. Now, all the different components under the hood for that system are under an umbrella term called a PKI, or Public Key Infrastructure. So that's what you'll see on the exam. They'll talk about a PKI. And the PKI is the collection of clients, certificates, servers, and other servers that are all involved in the system of making these certificates work.
Yeah. Now, what makes this really incredibly secure for us is the very fact that there comes down to the encryption part, where there's two parts to it. There's what we call the idea of a public key and also a private key. Now, this is going to be strange for us if we haven't actually been studying this before, but if you've been going through our Network Plus series, as well as the idea of earlier shows and our Security Plus, you ran into that term that we call symmetric encryption. Now, for all I know, we might not have actually done that show yet, but we may have, and I can't remember right now whether or not we have. We've covered so many topics so far.
You know what? It's probably a good idea for us to do an overview of that anyway, right? So when we're dealing with encryption, you've really got two categories. You've got symmetric encryption and asymmetric encryption, all right? Symmetric encryption is the most efficient. That's where I have one key, one little secret password or whatever that I use to encrypt data, and if anybody else has that same key, they can decrypt the data. So there's just one key involved. And I'll just use the example of a passcode or whatever. So if I want to send Ronnie something encrypted and I want to use symmetric encryption, I create a key and I encrypt my data with that key. I give Ronnie the encrypted data. I also need to give Ronnie somehow my private key. Now, I don't want to send it the same way as the data, because if somebody intercepts it, now they can get into my data. So I have to send him the private key some other way. I can give him a USB key that's got it on there. I can write it on a piece of paper and fax it to him, tie it to a pigeon leg, you know, whatever it is that I need to do to get him that private key. And that's the real weakness with symmetric encryption, is somehow you've got to transmit your private key over to that other person, and it's going to be susceptible to interception when you're transmitting it. So you might ask yourself, if it's so weak, why do we still use it? And the reason is it's extremely efficient.
Yeah.
It doesn't require a whole lot of CPU power and number crunching and all that to encrypt and decrypt the data because it's all done with one key.
And when there's a lot of data that needs to be done, we don't need anything with super heavy CPU impact on the CPU for us. What we need is good, solid encryption, and that's what symmetric key encryption provides for us. It provides a good encryption method. What we actually need to do is we need to protect that particular key, and we can do it again like the way that we were talking about here, in which we send it through a different method. But the other way, the true way that we encrypt it is that encryption key is by using something much more complex called the public key, or the idea of the asymmetric key encryption, which requires two keys.
Right. So asymmetric is more complex, but a lot of work has been done to hide that from the end user. So when you go to Amazon.com and it switches over to secure, you're actually doing asymmetric encryption. There's really a total of 4 keys being used in that communication, but you don't know that, right? It's all in the background, it's all hidden from you. So let me draw a picture and kind of show how this works. It's a pretty neat system, all right? So I've got here just my PC and Amazon.com, and so I'm getting ready to browse to Amazon because I want to buy the X-Files on DVD or something like that, right? So I'm trying to think of high priority things to go and buy. So basically, I'm going to fire up my computer and I'm going to browse over to Amazon. Now, when I do that, it's an unsecured connection, right? I just go to www.amazon.com. It's not secure, right? It's not secure unless I type https:// or if on Amazon's side they redirect you. And that's exactly what happens when you go to say like time to buy, right, or log in. They redirect you to a secure page. Same thing on the ITProTV website. If you come to our website, it's not secure, but the instant you click that login button, or if you go to update your payment details or something like that, it flips over to secure at that time. The reason companies do that is when you're encrypting and decrypting data, it does require processor cycles. So if there's data that doesn't need to be secured, like Amazon's homepage, right, or one of our videos videos don't need to be encrypted, and so there's no point in securing those, so you kind of flip back and forth. So when I go to Amazon, though, they're going to say, whoa, we're about to handle some credit card data. You need to be secure. To ensure that things are secure, they use a asymmetric encryption type, and they use a PKI, like Ronnie was describing. So it starts with a private key, okay? So at Amazon's headquarters, they have a private key. And the private key is a key that's used to, oh, that didn't change colors, did it? It's a key that's used to basically encrypt or decrypt data. It can do both. It's the same thing as a private key in a symmetric encryption model, all right? But Amazon will then take that private key, and based on your session specifically, just you, not the millions of other customers that might be on the site, just you, they will generate a temporary public key. Now, a public key is special because a public key, if I can spell it right, I've got a public key there. All right, so that's something different. That's all right. So so a public key is based on the private key, right? They run an algorithm against the private key to create this public key. It's a special key that can be used to encrypt data, but not decrypt it. All right. So the private key can decrypt. It can encrypt also, but it can encrypt or decrypt. The public key can only encrypt. All right. That's why they call this asymmetric, right? 2 different pathways. There's no symmetry. One encrypts, one decrypts. The private key is the sensitive one, right? That's the one that if an attacker gets the private key, they can decrypt your data. But the public key can only be used to encrypt data. So if an attacker gets this key, not such a big deal, right? They can encrypt some data. They can't read my data. That's what's important. And so what Amazon does is they keep their private key right there on their servers. But they take that public key, and you know what? I've set myself up for drawing failure here. So I'm going to rearrange some of my arrows and things here. So so they take that private key and they keep it right here on their servers. They don't send that over the network, all right? But the public key, they're going to take that and they're going to send it to me. And they're going to send it to me right across just the regular old internet. So private key stays right here. The public key gets sent over to my PC right across the regular internet, all right? If a hacker intercepts this,
Yeah.
big deal, right? But I get it, and now I can encrypt data and send it back to Amazon encrypted, and they can use their private key to decrypt the data and see what I sent.
Yeah, and so the nice thing about this idea is since the keys are matched up, if I take that public key and I send it to anybody else on the planet, they may go, what is this encrypted data? What does it really matter? Because all they're getting is a piece of encrypted data. But if we encrypt it, and Amazon is the only server that actually has the key to decrypt that data, well, now we've actually got a good communication going on here. And that's really part of the security behind it, right? We're never exposing the actual private key itself. Everybody gets a temporary public key that only allows them to encrypt it, and there's only one key that will decrypt that data. And so that means even if somebody else were to intercept that particular public key encryption that we were sending back, it doesn't matter. They don't have a key that will actually unlock it.
And then here's the really cool part, right? So once we've got the public key from Amazon, we then generate a one-time use, just for our communication with Amazon, private key and public key combo, and we send our public key back to Amazon. And we say, hey, Amazon, when you talk to me, use this public key. You can encrypt the data and send it to me, and I can decrypt it with my own private key. All right. Now, this is important, right? Because you might ask yourself, well, you're already getting encrypted data from Amazon. But if I punch in my credit card data and I hit submit, that's me sending stuff to Amazon, so it'll encrypt it with their public key and send it to them, and they can decrypt it. But then what happens? On their screen, it's showing things like the last 4 digits of your credit card and so on. And those are things you might not want an attacker to have. So Amazon needs to be able to encrypt data and send it to you, which means you need to be able to decrypt it. So remember earlier I said there's actually 4 keys involved in this process. Now you can see them. Amazon's private key is the only one that's permanent. Then we have the public key they generated just for us. They sent over to us. There's our private key, which is temporary just for our communication with them, and a public key that we're sending, again, temporary, just used for this session, sent to them. If I'm a hacker and I'm watching all of this communication on the internet, right? So we've got the internet in between all this. So if I'm an attacker and I'm out here on the internet and I monitor this whole communication, well, what am I seeing? At the end of the day, I'm seeing 2 public keys. And if I intercept those public keys, I can encrypt data and send it to Amazon. I can encrypt data and send it to my PC, but I can't decrypt it. So I can't figure out sequence numbers. I can't figure out port numbers. I can't figure out anything else about that communication, but I can try and inject data. But unless they completely astronomically luck out and guess the exact sequence number we're on and the signatures and so on, it's not going to work. And the signature is the important part. You know, all this stuff is being digitally signed. So, it's for all intents and purposes today, it's unbreakable.
Yeah, it's the basis of pretty much of all of our e-commerce right now. So without this, if we begin to break through this, then we've got a problem. But right now, everybody trusts it, so it's a good model for us.
Yeah. And you know, there was a article in the news just a couple of weeks ago when LavaBit shut down. Now I don't know when you guys will be watching this episode, so this may be old news for you, it may be new news for you. LavaBit was a company that provided completely private, secured, and encrypted email. And out of the blue, one day they shut down. And they said, that's it, we've been approached by the government and we can no longer operate in a secure manner, we're closing our doors. Okay, so what happened there? They used SSL to secure everything, they encrypted their own systems. What was the weakness? What made them all of a sudden decide we can't operate securely? Well, the weakness was not a weakness in the technology itself, but basically the NSA came in and said, you will give us a copy of your private key. You'll do it. And there's no arguing, no anything like that. You can't go to court, you can't petition. You will give me your private key. If they turned over that private key, then the NSA would be able to decrypt all their data at will. Instead, they chose to go out of business, which if you're a secure email company, then that's the right thing to do. So anyhow, so that was the deal there. There wasn't a flaw in the encryption, but there is this private key. And if somebody can get a hold of the private key, they can then decrypt all the data at will.
So when we start talking about this particular level of encryption, right, then we've talked about the symmetric and the asymmetric just briefly in terms of an overview. Don, this is where we actually get into what we're talking about, right? The idea of where in the world do we get these keys from? is where we're really going on this idea of the public key infrastructure.
Well, you know, I mentioned at the beginning of the show, trust, right? Certificates all come down to trust. When we connect to Amazon, they give us a public key. How do we know that's actually a secured public key and not one that, you know, has already been compromised by hackers and so on?
Right.
So we need some kind of trust. Internally, in our own network, we can set up a certification authority, right? That's a CA, or a certification authority, or certificate authority, however you want to call it, is a server that's capable of issuing certificates. Anybody can make one. You can make one in your house right now if you want. In fact, you probably already have. If you have like a router or any SSH device, then it acts as its own little CA. But nobody else is going to trust it, right? It's some random CA. So there are a handful of organizations out there, companies, that sell certificates. They sell certificates online. And what they're selling is not actually the technology of certificates, because anybody can do that. And it doesn't really cost them any money to generate a certificate. That's not what they're selling. What they're selling is the identity verification process that they do on the back end.
Right.
So the market leader in certificates is VeriSign. And here, I'll pull up VeriSign's webpage.
Yeah, it's the idea of the trust that we're talking about here, right? They're saying, look, we'll provide all these services, we'll verify who these users are, and we'll make sure that these are legitimate companies for us. And so when you buy a certificate, we can verify that. And so as we look at this website here, look, now from Symantec.
Yeah, you know, it's that means that VeriSign, if you're watching the show today, VeriSign is the market leader in certificates. But since Symantec owns them, if you're watching this video 3 years from now, VeriSign used to be a company that used to be in business and used to sell certificates. And I'm sure Symantec will drive them into the ground. Symantec is where software goes to die. But anyhow, you know, if you want to buy an SSL certificate, I can see it right here.
Right there,
SSL certificates. I want to go and buy one. So when you buy one from them, it's not just a matter of punching in a domain name and giving them your credit card. They're going to call you on the phone. Sometimes they'll ask for bank statements that show your address. They'll ask for various forms of identification to prove that you are who you say you are.
Right.
A lot of times they'll ask you to make some kind of modification to the website of the domain you're trying to secure so they can verify you actually control that website. It's identity verification.
Right.
They're making sure that you're not a rogue person, that you are the person you say that you are. And they're pretty thorough. Now, they'll sell different grades of certificates, so like their value certificates, it's usually just a phone call, you know. But then when you get into some of their higher ones, like their pros or their secure site ones, these are the ones where they'll start asking for bank statements and so on. And it's a big deal, right? Personally, while VeriSign is the #1 authority out there, I'm not a big fan of them. But there are other people that sell them. TrustGuard does. Thought Communications is another one. Here we go. Thought. They had a bit of a corruption scandal a few years back, so you never really know. But you'll see here where I can go in and buy SSL certificates from Thought, and what's their pricing is it's actually pretty rough, isn't it?
Yeah.
It's a little on the high side. So anyhow, these guys, you know, again, what you're paying for is them doing the research to verify that people are who they say they are, right? It's kind of neat. The certificates at the end of the day, there's a ton of companies that'll sell them, like Register.com, you know, GoDaddy sells certificates, but a lot of them don't actually issue their own certificates. They're reselling for VeriSign or Thought or somebody like that. So there are only so many of these companies out there that are really trustworthy. So how do we know? How do we know which ones to trust and which ones not to? Well, if you're a hardcore security person, you do your own research, you find the ones that you want to trust, and then you add them to the trust list on your computer. Most people don't do that. Right? So it ends up being our web browser developers that make the choice for us. So if you run Chrome, Google has a list of approved CAs that they trust, and by proxy, so do you. And Firefox, you know, the Mozilla organization, they do the same thing. Internet Explorer, Microsoft does it, right? I'm in IE right now. So when I go somewhere like, let me go to Amazon, since that's been my example here. I'm going to browse to Amazon, and I tried to go secure, and it redirected me. Funny. Here, I'll pretend like I'm signing in. We'll go online and buy things on the show. This is our new shopping series on ITProTV. Here we go.
There it goes. Yep.
So I just went to buy or to sign in, and I can see that it flipped me, so I now have HTTPS written up here in the top. And if I want to take a look at my page, so I'm just pulling up the properties of the page here, and I can see that I've got a certificates button letting me know that there is a certificate attached to this. And so here's the certificate that Amazon is using. I can see it was issued to www.amazon.com. It was issued by VeriSign, right? So that
Class
kind of
3,
reinforces.
there you go.
So here's a VeriSign certificate, and then it's valid until May 18th of 2014. Okay.
Now, Don, that date there, is that really important?
Absolutely. Yeah, you know, the older a certificate is, the more time hackers have had to work on it, right? In theory, given a fast enough computer or series of computers, and given enough time, somebody could work out what your private key is, right? It usually takes thousands of years, right? But in this day and age of distributed computing, where you might have a ton of computers at work, it becomes theoretically possible. So the rule of thumb is on a critical site, your certificate should never last for more than a year, all right? Unless critical sites, you might want to go longer. Like on ITProTV, we do 3 years, right? We do 3 years because we do not store any credit card information or anything like that. So if a hacker were to break into our data, they would get usernames and email addresses, right? And so that's not the end of the world. So going on a 3-year certificate, knowing that it takes hundreds or thousands of years to break it, that gives us the degree of security that we need. Amazon, though, they're processing credit cards. They store your credit cards because they do the recurring stuff. And so for them, they need to do a higher level of security. So they do 1 year.
Yeah. Usually when we actually start seeing this, right, one of the first things that you go, why in the world would I ever buy a 1-year certificate? It is because of that process there that today with the faster computers, we're actually starting to see that even 1 year might be pushing the limit at times. So you're starting to see shorter and shorter lengths in terms of certificates go. And that's a good thing rather than a bad thing.
Yep, absolutely.
Yeah.
All right, so you know, VeriSign in this case is the CA. If I go to other sites, who else could we try? Google, right? Google does secure searches now. And so if I take a look at their certificate, wow, theirs is actually issued by the Google Internet Authority. I didn't know they had their own CA. Apparently they do. They also have a 1-year certificate, expires September 25th, 2014. So yeah, I was not aware.
Yeah, there you go.
And apparently there is no, well, let's look at the certification path. This is another point. All right, here's our answer. So when you get a certificate, a lot of times it may look like it's from one company, but it actually isn't. It's from some parent organization. So I can see right here that Google has the Google Internet Authority G2, right? This certificate, for all intents and purposes, was issued by Google. Now, why do I trust it? Well, why do I trust Google? Well, if I go under certification path, I can see that it was issued by Google, and Google is a subsidiary of GeoTrust. GeoTrust is another massive SSL provider on the internet. So what this means is that basically Google went to GeoTrust and said, hey, GeoTrust, we need a lot of certificates. We need a lot. So I don't want to just be a regular customer where I buy certificates from you one at a time. I want to set up my own server where I can issue certificates at will across my entire organization, because we need a ton. And so GeoTrust said, all right, we can do that, but it's going to be expensive, which Google laughs at. And then they say, okay, here's the deal. We have to set up your certificate server. We have to manage it. It's our employees that control it. We need to monitor security on it to ensure that it's safe. But you, Google, can now issue as many certificates as you want under your Google brand name. All right. And so that's a great way for big companies, big organizations. Microsoft is probably the same way. Let's check out Microsoft. I'm in Internet Explorer, though, so Microsoft probably isn't using anybody else on this one. But let me see if they'll let me go secure. They will. Good.
Oh, nice.
All right.
There you go.
So if I look at theirs, so theirs is showing MSIT Machine Auth CA2. Microsoft IT is MSIT. And if I go to the certification path, I can follow up the route to CyberTrust, right? So CyberTrust is another big provider that's out there, or they're listed as Baltimore CyberTrust. That's where their headquarters is. And so that's what Microsoft is pulling off of. And they've got their own Microsoft Internet Authority. So, so you know, if it's a big corporation, they'll do that. if you're somebody like ITProTV,
Yeah.
then we just bought our certificate. Where did we buy ours from? I think Register.com. And Register.com is small potatoes, so so they
They're a wonderful company.
yeah. I've gone back and forth with them. When it comes to DNS like domain names, I love Hover.com. Hover.com is a great DNS registrar, but they don't sell certificates. And so a lot of times I'll buy certificates from Register.com because they're so inexpensive. But so here's ours, edutainmentlive.com from Register.com. But Register.com isn't actually, oops, that's not what I wanted, is not actually a issuer themselves. Yeah, they're built under User Trust. User Trust is another name for, shoot, what's their bigger name? Oh, dagummit. They have another name, and I just can't remember it.
Komodo? Is that right?
I think it is Komodo, yeah.
Komodo.
Yep. So, so Komodo, another of the larger providers. Komodo, they're the ones who did the circle of trust,
That's
the
right.
web of trust, or whatever, the web ring of trust.
Web of Trust, yes.
One ring to rule them all thing, something.
Wow.
Anyhow, so
Good reference.
So yeah. So anyhow, there are a handful of providers that are out there. If you want to see who you trust, if you're ever curious who you trust, it's actually pretty easy to pull it up. On a Windows box, there's a hidden administrative tool we can use that if you fire up an MMC, so if you just do, run and type in MMC, let me get past my security here, there we go. You can pull up the Microsoft Management Console, and in the Management Console, you can go to File and Add, Remove, Snap in, and I'm going to add in certificates. All right, and we'll just do the certificates from my user account.
Not your user account.
That's right. So what we're looking at now is our certificate repository. Not to be confused with the certificate suppository.
That's right.
But I can go into the certificate repository here, and I'll see like my personal certificates and stuff. And then you got this guy right here, Trusted Root Certification Authorities. And here's where we can see the full list. Now, who made this list? Well, I'm running Microsoft Windows, so Microsoft made this list. Here's a list that Microsoft says that I can trust. Here's CyberTrust, right? We can just look down the list. You'll see all the big names: Equifax, GlobalSign, GeoTrust is a big one. Let's see, who else is in here? Secure Trust. There's Thought down there. Thought's actually got several entries. And then VeriSign right down there. And then there's User First. That's the other name for Komodo.
Okay.
So that was where my Register.com one was coming from. So there's a list of providers. How many are in here? Will it count for me? 35. So there's 35 providers trusted by Windows by default. All right. If you buy a certificate from a company that's not in this list, and they're not a subsidiary of one of these 35 guys, right? So like if you create your own CA and it's not in this list, nobody's going to trust your certificate.
Right.
And when they go to your site, they're going to get a little red status bar, and it's going to tell them the certificate for that site is not trusted.
Yeah.
So that's kind of the idea of how that works. We want to go a bit further and show you guys like how to set up a certificate authority and how that stuff works. But for right now, we are running up on our break time.
Sure.
So, Ronnie, can you think anything else to throw in before our break?
Nope. I think we're ready for a break.
Excellent.
Yeah.
So let's stop here. We'll be back in a few minutes with more certificate stuff. All right, welcome back, everybody. So what I want to do now is to make sure that everybody has kind of a good idea of what's going on in the background on some of this stuff, and we're going to set up a public key server. Now, personally, if I'm going to set up a certificate authority, there are a lot of tools and functions in the Unix world that are a lot more powerful and stable and so on, but with the command line, you can't really see what's going on. So, so we're going to use a Windows server, which is perfectly fine. Just not as common out there on the internet. So I'm going to use a Windows server as my certification authority, and mainly because it's got nice little GUIs for it. So, but basically, really any server out there can be turned into a certificate authority. The missing piece, the missing piece of the puzzle is just trust, right? Getting those clients to trust your certificate authority that's issuing out these certs. So. So let's go ahead and pull this server up here. I've got a Windows Server 2012 machine, and to be honest with you, I've set up many certificate authorities on Windows servers, but not 2012. So it should be the same though.
Now remember the reason why we're actually doing this. A lot of times companies, just like what we were talking about earlier here, they want to issue out as many certificates as they need to without having to buy individual certificates each and every time. So instead, within a company, you may not need that internet trust authority. You may just want to actually be able to house your own, so you can actually come up with your own particular certificate authority. Allows you to issue out as many as you need to within your organization, and that way you can actually keep that trust within if that's all you need. And so this is what we're actually setting up here for us to see this. So as Don begins, what he actually did for us here is he has launched the wizard that helps to bring up the role that we need here. And so Don, I'll let you.
So what I'm adding the certification authority piece, which is technically the only piece that I actually need. But I'm also adding the web service for web enrollment. And this way I can show you guys, like, instead of going to VeriSign's website and buying a cert, I can go to my own website and request a cert and issue it for free. So just kind of adding that in there.
Did you add, did you want to do that?
Which
one too?
What?
This one? No, the certificate authority web enrollment.
Yeah, I'm just turning it on. It's part of the web enrollment piece, so that doesn't hurt anything.
All right.
So it has to install a web server to support all that, so it's installing IIS. I'm fine with that. All right, so let's go ahead and get it installed. So that's going to get installed. Now, one of the things that you may find is that if you're just doing development or practice work or whatever, you might not actually need a certificate authority. Many devices out there, access points, routers, even your own PC, if you're running IIS, for example, can do what are called self-signed certificates. A self-signed certificate is where you just generate your own cert, and you don't register it with a CA at all. Okay, I do this on Cisco equipment all the time, right? So if I want to SSH into a Cisco router or switch, I don't set up a root CA and do a trust and all that. You can, and by all means, that's the more secure method. But instead, I normally just generate a certificate right there on the system. And by doing that, now if I SSH into it, there's a cert available that I can use, and my session gets encrypted. The only problem is I don't have any way to verify the authenticity of that certificate. If I'm only using it internally on the network, though, that's not a big deal. If you've got a public-facing web service, though, it is a big deal, because all of your clients are going to get a warning message whenever they go to the site saying, we don't trust this certificate. Who the heck is this guy? So that's the problem that we're up against. And this is going to take a minute, so maybe I'll show that. Do we have a? Let me see. Is there a Cisco system I can remote into here just to show you guys how that works? Let me fire up good old putty. Here we go. So this is a Cisco switch that we've got right here in the office, and I SSH into this thing all the time. And if I take a look at its configuration, it'll have a certificate that, there we go. It'll have a certificate that's stored right inside of the configuration, and I can see it right here. And see how it says certificate self-signed. Instead of issuing it from a CA, I issued it right here on the switch itself. And you can do that on any Cisco equipment that has the encrypting feature set. You can use the crypto key gen RSA command. All right, that's going to generate a private key, and it's an RSA type certificate, right? All of our SSL certificates under the hood really are RSA certificates. So that's how we generate one. I don't want to do one now because it'll replace this one. But the thing is, people aren't going to trust that certificate. It's self-signed. So if I were to browse to that thing's website and do it securely, oh, apparently I have it turned off. So let me turn that on real quick. There we go. So if I were to browse to that thing's website, it's got a certificate, but see the warning I get? It says right here, the security certificate presented by this website was not issued by a trusted certificate authority. I do not trust the CA that issued the certificate because it's just some random switch, right? I can choose to ignore that though. And if I ignore it, I can connect to the system, and when I get connected, my connection is secured. It is using SSL, it is encrypted, but I still get the red bar up here letting me know that I don't trust that certificate. And if I look at it, here it says iOS self-signed certificate, and if I go to the certification path, there is no parent authority above there that's
Yeah.
somebody I trust.
Now, if you remember from our last segment here, this is where we showed you the certificate MMC, the Microsoft Management Console, and we browsed into that trusted root certificate authority. And what it's saying is, hey, I can't find a listing for this certificate or anything that this certificate is chained to. So this is where we actually start seeing this as well.
Good word. Ronnie mentioned chain.
Yeah.
You'll see that on the exam sometimes. They call it the certificate chain. And the certificate chain is the list of every certificate involved in that communication. So we saw that a little better with like Google earlier, where when I go to Google securely, there's more than one certificate involved, right? So when I view the certification path or chain, I can see the Google site issued by the Google CA, which was issued in turn by the GeoTrust CA. So all three certificates make up that chain, and all three have to be intact. But when I browsed to my switch, there was no chain, right? There was no chain because I just issued it myself right off of this system, and so there's only one step involved in that process. All right, let me check on my server, see how that thing's doing. Looks like it is done. Yep,
so
good.
succeeded. There we
All
go.
right. So we are now a certification authority. Isn't that awesome?
Yes.
So let's get into the CA tools here. I did click on it, didn't I? Yep, there.
Yes, you did.
Okay. All right. So here's the nice. Cannot find the file specified. Isn't that wonderful? So
Oh, neat.
hang on, it may not have actually finished the install. Sometimes in Windows,
Yeah.
when you add a role, it adds the files necessary but doesn't do the configuration. That's exactly what it did here. See how I was saying configuration needed? So let's go in and do that. All right, post-deployment configuration needed. And this is the part where it starts the post configuration, which it is not going to do for me. That's awesome. So let's see here.
Nope.
Well, dagummit. It's not making this easy for me, is it?
No. Oh, there it goes. It's still.
There we go.
It's still taking its time.
Well, it's
there
waiting
it
for me
goes.
to start
There
the
we go.
process. Okay, so we just need to activate the certificate server. So like I said, I hadn't actually done it on 2012 before, so they've kind of changed things around on me a little bit. But basically, I'm just going to go through and turn on those features that I kind of already told it to do. Let's see, cannot be installed on this computer simultaneously. Well, I'll have to come back and add that later. All right, so when you install a CA on Windows, they give you two choices, and they're pretty neat. One, you can do a standalone CA. That's when you're setting up a CA kind of like what these internet providers are. The other option is to do an enterprise CA, and this is neat because the certificate authority you create will be put into the Active Directory, and any other computer joined to your Active Directory domain will automatically trust this CA.
Yeah.
So really cool. You can build up a CA internally. All your internal PCs will trust it. You can now issue all the certs you want. And internally, your machines will trust it. It's pretty neat.
Yeah.
Externally, people aren't going to trust it. But they could add your root CA that you made to their trust list, and then they would trust it. You know, so that's how you can issue your own certificates without having to pay for them. But you're now taking on the burden of verifying that malicious certificates aren't issued. I'll go ahead and do an enterprise CA. Why not? All right. Now we get the question of whether we're being a root or a subordinate CA. A root CA, that's the big cheese, the head honcho, right? And I showed you like the 35 root CAs that Microsoft trusts by default. But there are subordinate CAs, like Google and Microsoft themselves, where they were subordinates of some parent certification authority. So if we're creating a subordinate CA, we can do that here. And if you have enough money, you might be a subordinate CA of GeoTrust or VeriSign or somebody like that. Or you might just be a subordinate of some other certificate server that's been built in your environment already. Since this is the first one, I'll just do a root.
Yeah, and the root certificate authority is actually the only one that gives itself a valid self-signed certificate, right?
Yeah, you've got to have one certificate to start it all, and that's the root CA certificate. And that's what it's asking me right here. Do I already have a private key to use for that root, or do I want to create a new one? I'll just create a new one. All right.
Nope.
Now it's asking for my key strength, right? And this is important.
Right.
You really want to make sure that your key strength is at least 2048 bits in length, and you'll see that's the default here. And you've got choices of several different standards to pick from, whatever the requirements are for your organization. Some aren't supported by every system, so you need to make sure that your various systems support it. I'll just go with the defaults here, which is a 2048-bit RSA key that uses SHA-1 digital signatures, so I'm cool with that.
Okay.
All right. And then, it just gives me my summary of the system name. I'd change that if I had a public domain name, but this is just internal, so I'll leave it there. Now, normally we only want our certificates to be, like a 1 year for the end stations. But for the root CA, you'll normally go longer, and the reason is when a root CA certificate expires, so does every certificate it's issued. And so you have to reissue. So you'll see a lot of them, like if you go to VeriSign and GeoTrust, they usually do 100 years on theirs, or 99 years. I'll leave mine at the 5 years here. All right, and then it's just asking for where to store them on the hard drive, and to finish up. All right, that'll get it configured, and then I'll be able to run my certificate tool. All right, so now that's being built up, and I've got a Windows 7 machine, and I want that Windows 7 machine to be able to get a certificate from this server. But before I do that, I need to add that web panel that it wouldn't let me add a minute ago. So I'm going to add that now. And yep, that's fine. Oh, wait, hang on. I want to do username and password. So if the machines were all in the same domain, we could just use Windows authentication and be done with it. But in this case, the machine I'm using is not on the domain, so I'm going to make it ask for a username and password. And, oh, I don't have a service account. We'll just use the pool identity. Well, no, we better use an administrator account. I'll break security practices a little bit here and just use my administrator account. With any service, when you secure it, you normally want to create a dedicated account for it, but I don't want to spend all day setting up the lab environment, so I'll just use that one. It's not in the IIS users. You know what? Fine. Pool account. Pool account it is. All right. And let's see, we don't need to attach a certificate. It should already have one when communicating with the clients. That's our root certificate. That one is fine. We could create another one, but that should be good for us. There we go. And that should finish it. All right. So if I wanted to secure a website with a certificate from a CA, normally we would do the whole certificate process. We would create a certificate request. We'd send the request to the provider. They'd digitally sign it and charge us money, right? You pay $100, $200, whatever. And then they send you back your digitally signed public key that you can then, or private key, and then you can take that and generate your public keys to issue out to clients. Since we have our own CA now, we can kind of cut out the middleman. We don't have to pay somebody. Now we can generate it ourselves. Now I've got a web server. I'm running IIS here. And IIS uses certificates, so it's it's going to have those certificates in place, and I can go in and issue a new certificate or change a certificate if need be. It should already have one, but let's just verify. I'm going to come in here to my web server, and what is it griping about? Oh, you know what? No, I do not want your web platform. I just want to use my computer. Stop plying me with services. All right, so I'm just going to come in here and go to my server certificates, which actually would be under server, wouldn't they? There it is, server certificates. I'm just going to verify that there is a certificate right there attached to my system. So that's good. I do have one. If I didn't have a certificate on my web server, see over here where I can create a certificate request? That's what we would normally do if we were dealing with an external provider. We would create this request. We'd fill out our data, and then we'd send that request to VeriSign or GeoTrust or whoever, right? Since we have a internal CA, we get a new option here, create a domain certificate, right? And if we do that, instead of going out to GeoTrust or whoever, it just goes right against our enterprise CA here and immediately issues out the certificate. And all of my clients that are connected to my domain will trust it because it's a part of that domain, right? So it's pretty neat. I could say, this is www.ITPro.TV, and we're part of the Edutainment Live Network. Our organizational unit is ITProTV. We are in Gainesville, Florida. They always make you type out the state name. Okay. And then I can specify an online CA, which we have one. That's the one that we just built up a minute ago. And I can give it a friendly name. I usually call it the domain so I can remember. And then I like to put in the date. So we'll put in the date that it was issued. And there we go. So now I've got a certificate. It was instantly assigned. I didn't have to go to a website and submit it. I didn't have to pay money. It just instantly assigned. That's the nice part about having an internal CA is you can quickly and easily generate these certificates, and it's not a big deal.
Right.
All right. But the problem is, if you connect to a machine or a machine connects to you that is not a part of your domain, it's not going to be trusted, right?
Right.
Which I just happen to have floating around back here. A trusty, dusty Windows 7 machine. And Ronnie, do you remember the certificate services website address?
Yes, it's CERTSRV.
Whoops.
So you go to the machine name.
Hang on, let me get Internet Explorer to stop offering me services.
What?
I know. Please set me up for Bing. I need it. All right, so I'm going to go to. Oh, I need to spell. How do you spell HTTPS?
Yeah.
10.1.230.203, I think is what that server was.
Yeah. SRV. Oh, well, maybe not.
Oh, I might have the wrong IP on the server. Let me just go check that real quick. It is 203. The firewall might be blocking it then. And right if I go, it is CERTSRV, so that is right. And let me just check the firewall.
Oh, yeah.
Windows firewall, you know, there we go. And we'll go to our inbound rules. And we'll hunt down our web server, or I probably could just create a new rule. It'd probably be faster. You know, Microsoft, they don't make it easy to find things in the firewall. It's not like IP tables in Linux where I can just pull up a config file and spot stuff real fast. Here we go. HTTPS traffic. It is allowed. Is it scoped for any network? Any IP address. And where's the policy thing in here? There. Domain, private, public. Actually, it is open. Let's go back to that machine.
Did you set up the SSL certificate?
I did. It was already there. I didn't have to.
Okay.
I guess I could double check that. Like if we try and browse non-secure.
Yeah.
Maybe it didn't actually attach it. So I should at least get the IIS welcome page. There we go. So that's working. And if I try and go to the certificate services page, it should fail.
Nope, there it is.
Gotta authenticate. All right, so now I gotta remember my password. Is that right? That's our challenge for the day. Hey,
look at that.
Right,
Yeah.
okay. Although, do you notice, Ronnie, it is not secured.
Yes.
We don't. So what I'm doing is I'm logging into the certificate server, and I'm about to request a certificate, right? But I don't want to do that on a non-secure connection, because if somebody's monitoring this, they'll be able to intercept my private key, you know, during the communication. So that's a bad thing. So I think maybe it didn't install the certificate. So let's go verify that. You know, great example though, where you really need to pay attention to that, where it looks like it's secured, but it's not. In IIS, you can pull up your site, and on the right side you have what are called bindings, and that's where you bind your SSL certs to the system.
Sure shows it.
And it does show a cert attached to it.
Well, that's weird.
So let's go back over here to my machine, and I'm going to flip it over to secure.
issue.
Yeah. In the Linux world, like with Apache, again, you've got some configuration files you can look at, and life is a lot simpler. So
that's weird.
that is strange. So I cannot browse to it securely. I wonder what is going on there. I mean, that seems like a firewall problem, right? You know, that it's not letting me get there, but, whoops, I did verify that rule in the firewall. I guess I could create another rule just to be on the absolute safe side. Let me just double check those bindings again. So it shows HTTPS on port 443.
I've got our, is that the right?
It's not attached to a particular IP address or a name, and it's got its certificate right there.
Wait. Did you?
Well, I mean, that's the self-signed one. I could switch to that one, I suppose. It shouldn't really make any difference.
I guess.
Well, see, on that one, it's going to be all ticked off because the name is wrong, too. Let me put it back to the other one.
Yeah.
So I just used an example name. But it is attached. Let's just do a quick test with the firewall. I'm just going to turn the firewall off temporarily. And we'll use that to test and see if it's actually a firewall issue. So with the firewall off, if I jump back to my client, all right, so it's not a firewall issue. Let me go turn the firewall back on. Anytime you do a test like that, right, you want to make sure if you turn the firewall off to test with, you always go back and turn it right back on. You know, we could also go and open up individual ports or whatever, but we'll just test that one. So it's not a firewall issue. I'm curious. I guess maybe something else is bound to that port already.
Yeah.
But I don't know what would be. That is really strange. Well, you know, I'll have to look into that during the break and find out what is stopping us there. But we are able to get to the site to request a cert. So before I even go into that though, let's take a look at something a little less troublesome. All right. So if I browse to that site, well, I can't even browse to it, can I? So if I browse to the site, I get there. If I try and browse securely, what I should be getting is that there is a certificate, but that I'm not trusting it, that I don't trust that CA. You know, who the heck is that CA? But from that screen, you can actually download the root certificate, and you can load it into your trusted providers. And we could do that from the cert serve page also. Like once I got logged in there, if I can get back to it, once you get logged in there, see how you can request a certificate, but down here you've got download a CA certificate, certificate chain, or CRL, right? That's where you can download the root CA certificate, their public key, not their private key, and you can load it into your trusted list, and then you'll trust that CA. And that's what I wanted to show you guys. It's actually safe to do that under a non-secure connection like this, but you know, but I wanted to show it under secure. So I'll go ahead and download this now, and so you'll see there it's picking up that certificate, and I'm just going to download the CA certificate. If this was Google and you know it had multiple tiers, I might need to download the whole chain, which is just going to download each certificate involved in the process. In our case, it's just one server, so I can download that one cert, and I can save it, and I'll just save it into my downloads folder here. All right. And then I can double click on that cert, and it's going to offer to import it. And when I import it, so here when I go to install certificate, I just need to put it in my trusted list. So I'm going to tell it to place it in the following store, and I'm going to put it in my trusted root certification authority. So when I do that, now, even though this is not an official internet-based CA, I trust them, and any certificate they issue, I'll trust. It still, you know, needs to be a valid certificate, not expired, correct name, and all that. But I do trust the root, so I'll install that, and now I'm good. Now, any certificate issued by that CA, I'll trust. If I was joined to the domain, that would have happened automatically. Since I'm not joined to the domain, I had to do that manually. So, all right. Well, I am curious why the secure part of that page isn't working, so I definitely want to take a look at that. But like I said, let me take a look at that during the break. You know, at a minimum, I should be able to get the welcome page secure, and that's not flying. So, yeah, so I'll tackle that. But Ronnie, can you think of anything else to throw in before the break?
No, I think we just have to figure out what that issue is, and we'll be right back.
Okay. All right, let's stop here. We'll take a break. When we get back, I want to wrap up showing you guys the SSL example there, and then we got a few other little technologies to tackle on before we wrap up the show. So stay tuned for more certificate services.
Right. Sound effects.
All right, welcome back, everybody. We should get to do some sound effects. All right, so you know, I wish I could give you guys some amazing technical, you know, craziness that I had to perform, some brazen feat of computing intelligence. But at the end of the day, I just restarted IIS and the problem went away. So in Microsoft fashion, you know, if something doesn't work, you reboot it. I restarted the web service, and now it's working just fine. So apparently, it just didn't bind to port 443 like it was supposed to. But it's working fine now. So when I browse to that certificate page, let's pull that up on my computer. So when I browse to that certificate page, I can see that I am able to browse to it with HTTPS now. And remember, before the break, I added that root certificate to my trusted store, so I don't get a red bar up here anymore. And in fact, if I click on the lock over here and I look at the certificate, I can see the certificate that I issued to that server, ITProTV-server1. I see that it was issued by that CA, and I trust that CA now, right? So I can issue certificates till the cows come home on that server without paying a dime, and I now trust it.
Right.
But I had to install that cert on my machine to create that trust, right? Now I do trust that CA.
So now for this Windows 7 machine, which is not joined to the domain, we should now be able to, through this website here, we're going to request a certificate. There we go.
Yeah.
We're going to request a certificate here.
Request a user cert.
And he's going to request a user cert. And
it's just warning that it's about to request a certificate for me, so I'll just go ahead and hit submit. So if I need a certificate on my Windows 7 machine, I need to request it, right? I requested it. Because this is a domain, I had to provide my domain credentials to log in. It's not going to ask me to pay any money or anything like that. Instead, it's just going to respond, and there it is, install the certificate. So, so it's generated a certificate for my machine, and I can install and use it.
cool.
All right.
Hey, look at that. It was
Sorry, I got this
installed.
sneeze is like right on the verge of coming out there. All right, so so you know, once you've done that, the certificate's installed, and I can pull up my MMC and look at that. Let me just go in here real quick and add my certificates. And then, you know, why would I need a certificate on my own workstation? Well, you know, maybe I'm doing EFS, maybe I'm setting up a little web server for development purposes. There's any number of reasons. But there's the certificate that was just issued to me. Actually, that one's attached to encrypting file system. Oh, multiple purposes, right? So under intended purposes, I see more than one thing. So if I go under here and pull up the intended purposes, which is buried in here somewhere. Well, you know, it's probably easier.
I think it's showing up on that first page.
Oh, was it?
Yeah, if you hover over in a hurry. Right there at the top.
Yeah, data on disk to be encrypted, protects email messages, proves the identity of your computer. So we can use it for 802.1x authentication. You use it for all sorts of stuff. So, you know, pretty easy to manage to have one of these running in your own environment. I did it in Windows here. You can do it on Unix and Linux boxes. OS X boxes can even do it. Not that there's a reason they shouldn't. But, you know, so you've got a lot of flexibility for setting up your own CA if you need to.
Now, Don, is there any real big problem with the certificates? Like, can they not just the expiration, right? Could it be possible that a certificate could corrupt?
Well, you know, you wouldn't actually see like the certificate itself break. That's pretty uncommon. But you could see a certificate become compromised, right? So let's say that a hacker, through whatever mechanism, does manage to get a private key, you know, for one of your certificates that you've issued. Well, that's where we need to make use of what's called the CRL, which is the Certificate Revocation List, right? And it's a list that every CA has to maintain. GeoTrust, VeriSign, they all maintain it. And when you create your own certificate server, it's got to do it too. And it's just a list of certificates that are invalid before their time, right? Every certificate has an expiration date on it. But there's other reasons why a certificate might need to be pruned off.
Yeah, so somebody could compromise it by stealing it. Some other issue here where all of a sudden, for one reason or another, we decide, just for whatever purpose, that, hey, we want to get a new certificate, whatever it might be. There is that CRL that actually gives us that list that we can now go and verify against. And if it's on that list, it means, hey, we're not going to trust it anymore. Yeah.
And I'll just pull up the certificate panel here on the server. So this is on my certification authority. I can go in and I can view like issued certificates. So here's all the certificates that I've issued from this server. And I can go to pending requests, and I can see ones that are waiting for approval. You can set it for manual approval mode. It's pretty awesome. And that's what VeriSign and those guys do. They're in manual approval mode. So they see the certificate request, and then they call you up and verify your identity. Fax me these papers. Once they have it, they then approve it, and it becomes an issued certificate, right? But maybe I get a call from, well, myself, and I say, hey, my certificate got compromised. I'm sorry. I was running BitTorrents, and somebody got hard drive access on my system, and I can see where they exported my private key. Can you invalidate that? All right. Now, my certificate's not set to expire until October of 2014, so that's a year from now. So can you expire it early? The answer is absolutely. All you have to do is, well, you know, right-click, all tasks, and revoke certificate. Any certificate authority can do this. And whenever somebody sees a cert in use, not only do they check the cert to make sure it's valid and trusted, but they also reach out to the issuing authority and say, hey, can I have a copy of your certificate revocation list? Can you see if this domain is on it, right? If this certificate is on it? And if it is, I'm not going to trust it. But if it isn't, I'll trust it, I'll let it through, I'll be happy with it, all right? When you revoke one, you specify various reasons. Key compromise is the most common, right? The key got compromised, somebody got a hold of it. But there's other things, you know, somebody might have gotten fired or suspended, you know, cease of operation, company goes out of business.
Yeah.
These are all reasons you might want to trim off a certificate. I'll do key compromise, all right? And you can set a date and time, so you can specify a time in the past or a time in the future. It defaults to right now, so I'll just say yes to that. And that's now a revoked certificate right there, and it's on my CRL. If anybody requests my CRL, they'll see this certificate right there in the list and know not to trust it.
Yeah. One of the things we have to remember here is that even though it's in this list, it doesn't mean that everybody knows about it right away, right? We have to actually do what called publishing the CRL as well.
Yeah, do you know, I don't know the default interval. I think it's like every 24 hours or something, isn't it?
I think so.
So different servers, different times. In Windows, I think it's every 24 hours it generates a CRL. If you're in a hurry, though, this is a big compromise. You don't want to wait 24 hours, and you can just right-click on the server, isn't it?
Yep.
And, well, maybe not.
Yeah, you should be able to go down to, no, it's on the revoked certificates, yeah. And then go to all tasks.
There it
and
is, publish.
Yep.
So if we you know, right-click on that and choose to publish, that's going to immediately update the CRL. You can, since it's the first time, I'll generate the whole thing, but normally you do a delta, just the changes to the CRL. So I'll do the whole thing. So that's going to publish it, and now it's available, and people will see that. So if you're in a hurry, if this is a big compromise, then you need to push that out right away. Yep, good point.
Yep.
All right, that's a pretty good rundown. Are we leaving anything out, Ronnie?
Well, we got just a couple of other things that the exam pretty much calls out, which is about backing up the idea of the certificate.
Okay.
And so when we talk about that idea of backing it up, this is important because these certificates, they really do hold the key for everything that we do that's encrypted. So we want to make sure that maybe our computer crashes or something, and we want to generate that key back, or we want to be able to have a copy. I can't say copy. A copy of that key. I was going to say a capture of that key. That's what we want to do. So what are some of the methods that we can actually think about?
Well, you know, on your own internal machines, you can export your private key, right? And in Windows, you do it right to that same MMC panel. In Linux, you know, you got your various command line utilities that do it. But you can export the private key. It's just a file. But if somebody gets a hold of that file, you're screwed, right? So it needs to be put on a USB key or burned to a CD or a floppy disk or whatever, and then locked in a vault somewhere, right? If you have a fireproof safe, it's a great place to put it, and make sure that people can't get at it. But if you ever need it, you've got that backup. Another option is to use a key escrow service, and I'm not too keen on these. They are pretty secure, but there are numerous companies out there that offer key escrow services where they will store your private key for you, right?
Yeah.
Now, that immediately sends up a red flag with me. Like, wait a minute, I'm just going to give these guys my private key? In the case of some of them, like if it's your issuing authority, they're the ones who issued you the certificate in the first place, so it's pretty safe. But if you're using a third-party key escrow service, there is a, and Ronnie, you explain it better than I do, the process of securing that.
There's a particular, I guess, type of key escrow service that we call, and I'll have to remember, M of N. So when somebody was saying, can you say that again? I was like, M of N. So it's Mike of November. Mike of November. It's kind of weird, but it essentially allows us to take that private key and store it in multiple parts. So let's say that I want to actually break it up into 5 different parts. Well, I can actually say, hey, I want to ensure that I don't need every single part, but I need 3 of 5 parts before I can actually get that key all back together. So that way we actually distribute the keys among multiple of those key escrow services, and then we can bring those pieces back together, and there is a way that we can actually regenerate the actual key that we have. So that way, instead of actually having to worry about this one guy has my entire private key stored here, we instead can distribute out. I hate to say it, it reminds me of Harry Potter and the guy that broke his soul into 7 parts.
I wonder if he used a soul escrow
that's
service.
That's right, yeah, an M of N escrow service.
So it is cool because the escrow services, they only contain a fragment of your private key. And then when you get enough pieces of it back, it's kind of like RAID 5, right? Like with parity, and you're able to recalculate and build out that entire key from it. So it does give you that degree of security. If it sounds complex, it is. A lot of the root CAs, GeoTrust, VeriSign, and so on, they actually work together
Right.
and do that with each other for their root certificates to make sure they've got that backup stored in a safe and secure manner. And they probably do the same thing with their souls. We have to see. So, you know, looking at the list, Ronnie, did we leave? Oh,
I think recovery agent.
Yeah.
There you go.
All right, in a enterprise environment where we're issuing out tons of certificates, right? Let's say that our employees are using Windows and they're using the encrypted file system, EFS, right? EFS uses certificates, and if you've got an enterprise CA, that's where the certificate's coming from. And let's say that an employee gets fired, or you know, and they leave, and their user account gets disabled, or gets deleted, right? User account gets deleted. Well, when the user account gets deleted, so do their certificates. Maybe a year from now, you come across a file that they had saved, and it was encrypted with their cert. But their cert is gone, right? So you no longer have their certificate. You're sitting here looking at these encrypted files going, great, how am I going to get at these, right? Well, when you use systems like that, a lot of them have the functionality built in that's called a recovery agent. And it means that you have some kind of super cert, some kind of special certificate that's usually an administrative certificate that can be used as a secondary decryption key so that you're never truly locked out of your data. Right. Microsoft calls it a recovery agent, so do many other vendors that are out there. And in an enterprise CA environment, like what I built here where it's tied to the Active Directory, it's automatic. If you're in the domain admins group, you can use the recovery key to be able to decrypt other people's data.
So it helps as another way of backing up, ensuring that we can always get access to the data, just in case there is another key compromise, or like we said, I always think about the idea of somebody encrypting it right before they end up leaving because they're a disgruntled employee. You go, I'm going to encrypt everything, and then I know what they're going to do. They're going to delete my account, and that all that data is actually encrypted. You know.
Now, personally, I don't like the idea of recovery agents. I don't like the idea of this super key being out there that can decrypt things. So I don't normally issue that to people on the networks that I work on. So if you're a network admin or whatever, I don't normally give you access to that key. But instead, what I do is I never delete users. If I fire an employee, I just disable their account. It doesn't cost you any money. You know, it's not like it's occupying space on the floor or something. You just disable the account. And that way, in the future, if you stumble across a file that they protected, all you have to do is go and change their password and re-enable the account. You can log in as them, decrypt all the files, and log back out, disable the account again. Very, very simple, very easy to do. I do that in Windows as well as Linux. Real easy to disable accounts. Really no point in deleting them. In my opinion. But, you know, who asked me? All right, so I think that's a pretty good rundown of PKIs. Now, Mike and Nate and Wes have been doing some other shows, and they'll talk about things like smart cards, which are really just storing certificates on them and used for authentication. They can be a part of that PKI also. So there is more to it, but as far as the exam is concerned and as far as the basic principles, that's pretty much the rundown of certificate services. All right. Ronnie, can you think of anything else we need to throw in?
I cannot think of anything on a certificate service that we need to actually add in here.
Okay. Well, on that note, why don't we go ahead and wrap things up. As always, if you guys have any questions live during the show, you can go to ITPro.tv/live, and you'll see the chat box right beneath there. Feel free to throw in your comments, and we will answer them live during the show. We love that stuff. Nate, our producer, has been kind of chiming in during the show today, but no real questions from the field. If you have questions and you're watching this show later on, if you're watching it pre-recorded, or previously recorded, not pre-recorded, anyhow. But if you're watching it down the road, remember you can always go to ITPro.tv, and on any of the certification pages, you'll see a link that says Q&A. You can go right in there and post your questions. We monitor those and respond. We love to answer questions. So just remember, you're not on your own. If it's a really good question, we may even do a special show on it just to answer it. We do that from time to time also because sometimes it's a lot easier to show than to write out a response. So just keep that in mind. You got those resources available to you. Also, we got more Security Plus coming up this week. I think we have a Security Plus show every day this week, which is pretty awesome. So definitely stay tuned for more of that. And then we've got our other shows that are running. Windows 8 is filming right now, as well as Network Plus and CCENT. We got more on the horizon. If you're watching the show in the future, those will be done, I'm sure. But always stay tuned for that. And then just check back with ITPro.tv for the latest in certification news. So. All right, well, ladies and gentlemen, I hope you enjoyed the show as always. Signing out for ITProTV, I'm your host, Don Pizzette.
And I'm Ronnie Wong.
And we'll see you next time around.